Здравствуйте, уважаемые дамы и господа.
Good morning, ladies and gentlemen, dear colleagues.
Ladies and gentlemen, today we are going to discuss one of hot point in our nuclear industry, SMRs, small modular reactors, or maybe as some years ago, agency used small and medium-sized reactors, but it's dualism in terminology. Take into account that we have a lot of participants and a big list of speakers. I would like to our speakers take your seats, and I'm going to introduce our speakers. First of all, okay, I will speak in Russian. Во-первых, я приглашаю.
First of all, I would like to ask speakers to take seats. Vladimir Andrei Nikipelov, Deputy General Director, State Corporation Rosatom. Mr. Li Feng, Deputy Director, CNNP. Evgeny Pakermanov, President, Joint Stock Company RAOS. Alexei Ferapontov, Deputy Head of the Federal Service for Environmental, Technological and Nuclear Energy Supervision. Independent expert from Hungary, like me, Imre Pastor, from Hungary. Deputy General Director,
МАГАТЭ Чудакова.
IAEA, Chudakov, Deputy General Director, Rosenergoatom, Pavel Ipatov.
Министр энергетики Приморского края Андрея Львовича Леонтьева.
Andrei Leontiev, Minister of Energy for Maritime Region, Primorsky Krai. Later, Sergei Velichko, Managing Director of Augment Investments, will join us, and we're going to work online with Mr. King Lee, Head of Policy and Industry Engagement of the World Association. So please take your seats. I would like to and Sergei Yevgenyevich is here with us as well.
I would like to invite our colleague from Brazil, Mr. Arpet Marques Peixoto, also to take his place, his seat. My friend from Indonesia, head of BRIN Research Center, Mr. Taipan Setidupura, and Executive Director of NEXA, Mr. Laiso Tabashe. Два слова перед тем, как начать нашу панель.
Just a few words before we proceed with our panel discussion. As you can see, we have as many speakers here as the audiences during the opening of this forum, but the small reactors is one of the hot discussion points which is now discussed all over the world on different levels. And there are great expectations connected with this, especially as regards the solution of climate problems and also in promoting the nuclear energy solutions, one of the most acceptable forms of energy production. Today we are supposed to discuss here that such technological solutions are available. If there are any difficulties on this path, regulatory and others, we would like to hear from our colleagues their comments and what exactly the countries want to do, what the investors can do, and ask the representatives of international organizations how the international community is going to help everyone to deal with these tasks. I am trying to avoid the word problem, so I would like to ask our colleagues not to use the word problems, because whatever is related to small reactors are political, technical, and other tasks that we must resolve somehow. So I would like to invite here for welcome word. Please, Andrei Vladimirovich, if you can turn on your microphone and we'll begin our panel discussion. Good morning.
Очень радостно видеть.
I'm really pleased to see all of you here. So there's two news. Despite the fact that we discussed small energy, we were given a big room, and also we are in good mood today, and I'm very happy to see so many interested participants, which demonstrates that there is a great interest in small energy solutions, and it is growing. And yesterday we realized that we are gradually moving from energy towards environment, ecology, and towards everything that is related to new materials and new movements. So as we are now moving away a little bit from our subject of discussion, after the main subject, the energy. But at the very beginning, they were saying that nuclear power generation is the greenest of all power generation types, and it can be easily forecast, and no doubt it may have different dimensions, not only big nuclear power plants, but also smaller plants, micro plants, and of course we feel there is a great interest, a big interest all over the world in this project. From 70 to 80 projects are now underway all over the world, which are dedicated one way or the other to the development of smaller nuclear power stations. But, well, there are a lot of projects, but there are two countries which lead in this area, Russia and China, and I hope there will be quite much interesting information what China is doing in this area and what Russia is doing here. So, and we will hear the owners of the technology and the customers. I hope there will be a very interesting discussion. So good morning and welcome to our session. Thank you, Andrei Vladimirovich. And since you mentioned China and Russia as the key players on this area, so I would like to give the floor to Mr. Li Feng, who will tell us about the Chinese program and the work in the area of small reactors.
Dear
guests, friends, colleagues, good morning. I'm so pleased to be here with you in this room because I would like to get more experience, more knowledge. And first of all, I would like to express my condolences to those to the people who suffered in the terrorist act. But now I would like to tell you about Chinese way of developing nuclear power energy and the small reactors in particular. I will share this in two aspects. The current situation, and the second is the challenges and what the chances are in this area. At this point, nuclear power energy as a role is growing, and China, just as other countries, are interested in developing this. At the 27th UN General Assembly, our chairman, Xi Jinping, said that by 2030 50, we will reach the carbon neutrality and will be a peak production. Now we can see the situation in China regarding the availability of energy units. We have five existing energy plants, and 20 more are in the state of construction. As you rightly noted, Russia and China are developing nuclear energy. So our corporation possesses owns 25 units, and we are building another 15. So I think in the nearest decade, we of course are going to boost the production of power plants, but I think the specifics of this energy is well known. There's small reactors, and they have certain advantages, as you know. In China, as you know, we have the ISR 100 high temperature in Shandong, in Shidawen, gas cooling. Gas coolant is used there. So precisely right now we're building these nuclear power plants, these units, and the most important thing that help us to reach a sustainable energy supply. It's called Lilun 1 right now. So that's how we call this power unit. 650 megawatt in Hainan, in two units like this, 650 megawatt each. So right here you can see these two plants which are in operation right now, while other units are still under construction. We are building, in accordance with NCPP contract, two more reactors in Hainan. We have developed a kind of a base for the construction of small reactors. We also have two power units for 1200 megawatts, Hualong 1 HPR 1000. So precisely the water cooling energy power plant is shown. The ACP 100 plant is demonstrated on this slide. So the overall situation here, as when we started building this in 2021, we began this construction project, and we hope that it will be commissioned towards December this year. Lilun 1 reactor will be implemented in this particular project. So right now we're moving quite successfully towards the completion of this project, and also as regards the construction, you can see here ACP 100 we began in 2021, so in 2025, so we have plans to launch, to commission it for commercial operation. So I've told you about the current situation regarding the construction and the owners of the power plants. So now I'll tell you a few words about the challenges and the chances and the opportunities. So here you can see some statistical data, 83 different technologies in the world which are used right now, varying in types of cooling, natrium, gas, and other technologies, 45 different technologies for where water is used as a coolant, 21 high temperature reactors, 13 salt cooling technologies. Lead is also used for cooling, natrium. So right now in the United States there are 20 technologies which are actually applied. In Russia 17, and in Russia 10 types of different technological processes that are used for these reactors. So hopefully the situation right now is as follows. So by 2050 we have to ensure that 1.5% of nuclear power generation will account for the world power generation. And so precisely as regards the construction, all countries are trying to build small reactors, because small reactors can be located next to big cities where there's a high population growth. And of course the government supports all these projects, but anyway there are certain challenges, and the choice of technologies, the human resources, supply chains, supervision in this area. Therefore, this situation as regards the coolants, which are used in different technologies, well, in fact, they can also be used in a flexible manner, so they can be used later on in different areas of the economy, in agriculture, in iron and steel industry. Therefore, we try to share the benefits and our knowledge with our colleagues regarding the benefits of smaller reactors and what kind of assistance they may give to other areas and other industries. So here you can see the plans drawn up by organizations. Hopefully the colleagues are aware of the situation and the position of the state supervisory bodies, financing sources, different stages of nuclear fuel production. In China, well, talking about the development of small reactors, of course, we've accumulated expertise, and we've already achieved certain good results in the construction of small reactors, but the most important thing here is to find the right way and to establish a good interface with supervisory regulatory bodies, and also how to use the specialists, the experts who are going to work at these stations and who are going to take care of the security, safety issues. But there are a lot of aspects here: how the fuel is going to be supplied, stability in supplies and deliveries, also the problems of safety, labor safety, the equipment, how the contracts are going to be signed, and so on and so forth. But we have quite a stable basis for all this. I mean, regarding the fuel and equipment, we already identified the sources. Therefore, I'm sure that we are going to implement all these plans. Therefore, I'm really happy to communicate with colleagues and to tell you about our expertise. So I urge you to share your views with us. As I've mentioned already, that we've already we have ample experience in different projects in implementing the nuclear power generation projects, the management and control over the stations, personnel training. So we have quite mature technologies and good methods of operation. So that's why I'm ready to share our expertise with you. Thank you. Thank you very much for such a detailed account and explanation of your program. Let me give the floor to the Russian vendor, Yevgeny Pekermanov. We would like to hear from you about the prospects for the development in this area and your view of the vendor in terms of regulation. Good morning, dear colleagues. My name is Yevgeny Pekermanov. I'm going to talk about the ground-based small nuclear power stations, and after that, colleagues will tell us about other types of power plants. Now, first of all, regarding small size stations, it's quite obvious that it is possible to deploy them in smaller areas, and as regards the requirements for the site, they are radically different from the requirements for bigger stations. Well, everything depends, of course, on the actual capacity, design capacity in a certain projects. And when we talk about modular stations, that's first of all we are talking about the possibilities to scale up these capacities, which have to match the relevant projects. What the Chinese colleagues said is the shortening of the construction time. Well, of course, we can build much faster, and we can use the modular principle during the construction, and also there is a chance to implement the projects within shorter time period compared to bigger stations. And of course, the great benefit is the optimal fuel company. The project that will give us a real advantage, and of course the room for maneuver, which is highly important as regards the project we're talking about, Rhythm 200, the maneuverability of this project is highly important, because we are talking about decentralizing the system, and there is no possibility to build this into a bigger system.
Значит, что мы сейчас делаем?
What exactly we are doing right now?
So we implementing right now in Russia the first project, ground-based plant. For this very project we have chosen, and it's very important, referential technology reactor 200, which already is in operation, and it showed all its parameters, technical parameters and security parameters. And right now our task is to earthen this technology to the ground-based platform site. Of course, this project is being changed a lot, considering the fact
специфики уже не.
If we look at the specifics, not just Navy operation, but ground-based operation, and of course we adapted to the federal norms and regulations, requirements, which is on for the ground-based nuclear plants, and nevertheless we consider this technology to be pretty promising, and this project is been implemented in Yakutia Republic. This is the extreme north of Russia, and it will be directed to the energy supply for the major non-developed gold deposits to choose, and this is long-term operation for more than 40 years of development. So that's why this reactor will be working there for the whole time, and it will be providing this production object the power, and that's why all the objects which are around it will be supplied with pure energy. And for today all the preliminary research is made, all the design documentation and project documentation is prepared, and today, together with Rosatom, we are going through the licensing process, and we gave all the documents to Rostechnadzor, to supervisory body, and we are sure that we will show it to our regulator, and we will get all the licenses. So right now we are making some initial preliminary works, and by 2028 we have to come to the stage of operation of the reactor in the mode of the real operation. So it will be power commissioning, power launch, and we will generate constant energy, and we will provide the development of the gold deposit, gold ore deposit. And coming out of the experience which we have right now, I would like to talk a bit about the changes which are necessary
нормативно-правовую базу и российскую, и международную.
for the regulation to be provided,
Сооружение и эксплуатация
so that the construction of the SMR would be optimal. So that's why all the legislation around this this industry, we commission water SMR, and considering the specifics of SMRs, all these necessities, all these requirements sometimes are excessive, and sometimes because of technological peculiarities, we can use them without putting some changes into them. So that's why today there is a huge work in ACT, institutional work together with a Russian technical supervisory body for the application of the legislation, so that we would license it and we would provide the process of operation optimal. So in our range of SMRs for today,
перспективное для сооружения в качестве наземных.
As the promising ground-based reactors of low capacity, I would set aside three technologies. Technology of the reactor rhythm 200, and then the reactor rhythm 400, which we talked already. It's ice-breaking technology. It's a small reactor shelf M, with the capacity up to 10 megawatts. This is the reactor of capsule type, where the equipment is made in protective capsule, and it's been developed for project of low capacity, but it allows to transfer to go to another type of the construction, because this is the capsule with the main technological equipment, which is brought to the site, and then with some expiration of the term, it will be extracted and it will be put into recycling cycle. And also a reactor of the fourth generation with different principles of safety, which also require a drastic change of legislation and norms. So what we can see as the range of parameters which allow us to talk about changes of requirements for the normatives and legislation. So if we talk about Yakutia and consumers, all the calculations which we get, we understand that sanitary protective zone is being merged by the site of the nuclear plant. So that's why we can talk about location of SMRs closer to the consumer, closer to the production consumers, to the settlements, and it can give a huge advantage to the remote areas because we understand that it's energy consuming, labor consuming, and technology consuming. So then another choice of the selection of the platforms of location. We have pretty rigid and tough requirements for energy grids as per water reservoirs and infrastructure. I would say that, for example, SMR will require 800 less times of water consumption than usual reactor. That's why, of course, water supply should be there. We have to guarantee water supply in operation mode and in emergency mode, but it's a completely different story. And you know, in Jordan, for example, they took this solution not to build reactor at all because they were not able to supply water to the reactor in the normal way. So that's why there are different opportunities. And if we talk about reactors of the fourth generation, we have the mechanism of the self-protection, internal self-protection, and we can decrease some measures of safety, but of course we have to keep all the norms and requirements of the safety issues. And the last slide, what we can see is the opportunity of placement of 2 and more reactors in one building. Of course, it allows us to optimize the systems. For example, if for example, holding reservoir can work for several blocks with the special, of course, calculations and on, so that it provide the safety of the station. Of course, it will decrease all overhead expenses and operational expenses, and it will provide energy supply parameters which are necessary for this construction. As per nuclear energy structure, our Chinese colleague had a great slide where he showed 19 parameters of infrastructure, of nuclear infrastructure, which should be in any country where they implement consecutive project. Of course, we have to be attentive to the requirements, and it should be implemented on the level of IAEA. And when we create this huge infrastructure for major units, but if you want to build SMR with 100 or 200 megawatts, of course it's very difficult to keep those parameters, and sometimes you can see that those requirements are excessive. So that's why parameters of SMR and PP should be again revised as per the requirements for nuclear infrastructure. So on one side we optimize it in security and safety level, on the other hand it will be economically efficient. And that's why regulators will have a huge role in this, because as per national regulators and vendors, they have to take leading part and role in interaction with regulators of
стран ньюкамеров, где
countries, newcomers,
реализовываются проекты. Ну, потому что, опять же,
where they are going to implement the project. Because to create a completely brand new sphere and to create new regulator for low capacity nuclear station, it's not really feasible and
дает гарантии.
reasonable. But if regulator gives the guarantees that constructed station is according to all the norms of safety, so then, of course, we can talk about implementation of the project according to other principles for newcomers countries. Thank you very much. Colleagues, well, at first, according to our scenario, we already set the timeline for the internal discussion for our speakers. And our next speaker factually will answer the questions which were asked by Evgeny. But after our two speakers, I want to remind to our colleagues that we have pretty rigid timeline and schedule. So that's why, Alexei, are you able to talk in 5 minutes really fast about the challenges which Evgeny was speaking about? Greetings to you, dear colleagues.
Я себе, в принципе, как и многие другие россияне, давно уже давал слово
And you see, I didn't want to talk a lot about
российскими афоризмами.
Russian phrases and sayings, but you know, in brief.
Пишется вместе или раздельно, и тогда я уложусь в 5 минут.
So kind of, I will try, of course, to stick to the agenda. And in my speech, I will try to be as short as possible, and I will talk about specifics of safety regulations in Russian Federation. At this very slide, I won't read everything.
Российская Федерация развивается.
And I will talk about the development of energy sector, how we develop our foundations for nuclear safety and nuclear regulation. So according to those documents, we can set aside special direction as per development of atomic energy use. Here we can see lead cooled reactor, Bresto D300, then SMR power plant, then reactors shelf type, molten salt research reactor, HTGR, and we can see different use like floating energy stations and ground-based stations. So I won't talk about the use of and applicability of all these technologies. We discussed about it a bit, and it's pretty obvious. So I would like to mention that in 2014, at the platform of AIEA, we created special kind of council of safety issue, and since 2020 we try to find some general common approaches as per the issue of production of energy, but all regulators, considering all the leading countries, vendors, I won't list them all. So all this forum was made under the aegis of Russian Federation, then United States, Britain, China, Japan, and then we finally understood that requirements to SMRs will be the same as to high-capacity reactors. The only thing that we would decrease the volume of documents which are applied by a regulator in this regard. And then we understood that unless we would come down to the revision and supervision of all the solutions, nobody would make agreements between themselves because general requirements, it's like, you see, when we interpret Torah or Bible, so there are some general approaches how to implement those concepts so that as per protection for salt reaction in security issue. So then we wouldn't design them at all.
В России мы остановились на
In Russia, we
которые
stopped on several projects which are being implemented. So these are
свинцовым
lead
носителем это реакторы судовой
heat
технологии,
reactor, then the reactor of floating technologies, which are reactors which are regulated on the nuclear icebreakers starting with 1970s, so then we don't need some additional regulation. And then it's high TGR reactors.
Быстро пройдусь по двум технологиям,
So right now I will talk very
которые
quickly about two technologies and about our experience which we got out of it. So we transferred
реактор Риттер
ship reactor, floating reactor 200 from the Navy use to the ground-based use. So right now 6 reactors are in operation and 2 icebreakers with nuclear reactors are being set and adjusted in the Baltic plant.
конструкции этого дизайна на землю оказывается.
So when we transfer this design to the ground-based use, we can see that there is an absence of requirements of ground-based technologies in Russian Federation,
Компоновка
where the setting of it is absent, the methods of welding and the methods of control is absent. So that's why we had to adjust our federal norms and standards, which were developed before we were issuing licenses, including reactor 200 in ground-based use.
перечень всего того, чего мы
The list of everything we've done or are doing at the moment.
значит, лицензия, которая
And the license that was issued in 2024,
ожидается выдача лицензии
we
на
are
сооружение.
expecting another license of the high-temperature gas reactors.
Проблем.
We face a great deal of problems here,
Концепция
also related to the concept of deep-rooted protection, which is written into the requirements for standard reactors relating to natural circulation, especially the things which are especially hazardous for high-temperature reactors with lead elements. So right now they are under construction. Yesterday, all of you saw the direct broadcast regarding the fuel supply system. But in the meantime, there were 3 documents issued on the high-level documents, the federal rules. Then there were 19 technical standards that were also issued in addition to these high-level documents, because any technology requires special consideration by the regulators. Otherwise, you won't be able to do anything. And the last thing I wanted to share with you is last week there was a working team on high-temperature gas reactors meeting under the umbrella of an NDEP program, the Paris agency. That's one of the 2 groups, actually, 2 teams that were set up to deal with specific technologies of small reactors. Here there was a traditional technology that was implemented in China, and the Chinese colleagues from the operator company, the representatives of the regulatory bodies shared their experience, 20-year experience for implementing this technology. We've considered the project in Russia. Conceptually, it is similar, except for some minor details regarding fuel, but this will also require the interference of the regulator. In June this year, in Turkey, a workshop is going to be held on small reactors and the A200. There will be an Argentina project, and the Chinese colleagues also promised to share the technologies and the regulatory concepts that they've implemented already. Thank you very much. Sorry for taking so much time. Thank you, Alexei. Thanks a lot. I think it's quite an important presentation indeed. Just a few words. Our assistant Ekaterina will indicate time and reminding you that you're running out of time. Just following up on the subject of licensing, I would like to give the floor to Imre Pastor, so he could share his expert view how it's going to work in Europe. If we judge by this top-level summit that was held last week in Europe, there are a lot of those companies willing to build small reactors. What's your view of this problem from the viewpoint of the regulator?
In the name of the organization PAX2 company, which is the new build company for the nuclear power plant PAX. First, I would like to express my condolences to the Russian people because of this terrible terrorist attack on Friday. I would like to try to concentrate on those aspects which was already somehow mentioned earlier, but maybe needed some more clarification. First of all, some figures. In Europe, in Western and Central Europe, there are at least 12 countries which are planning to introduce the SMR projects in the medium term. We have learned that there are around 80 different designs already on the table, and if the new nuclear renaissance is coming, then 70 SMRs per year are going to be implemented. These are huge figures and require some game-changing attitudes in terms of implementation and licensing as well. What I mean here, my colleague from IE, I think, will more tell about the nuclear safety harmonization initiative, which is the goal of which is to have a set of harmonized requirements which can be used for many countries instead of having a nationwide attitude of the regulators. Why it is needed? It is needed because if you look back to these figures I was mentioning, it is very difficult for each, especially for small countries, to be prepared to evaluate designs, so many different designs, and also make the licensing procedure in the timely manner. That's why in Europe we have a so-called SMR partnership, which goes from the owner side to collect all the aspects of the implementation issues, and also there are a lot of done in terms of requirement harmonizations with such institutions like EUR, for example, or WENRA. And as a goal, as a general goal, we would like to reach a common understanding and somehow the synergy effect of the efforts of all interested participants. And one more issue. We are dreaming about the mass production of the nuclear power plants, but we have to also consider the mass production of the experts needed for this. I would like to remember you that it was actually mentioned by our Chinese colleague that not only the investors have to have expertise, but the regulators in very high number of the experts is needed. And pupils need to learn math more than now, I think. Thank you very much for your attention.
Thank you, Imre. Спасибо большое.
Thanks a lot, Imre.
Обменялись кое-какими.
So we shared our views a little bit in the first stage of our discussion. Now I would like to give the floor to Andrei Vladimirovich. Would like to ask him to touch upon one of the most interesting subjects in the area of small reactor use, is the floating power units. So please, Andrei Vladimirovich. So we have a video clip about this, as far as I understand. So I will try to be as brief as possible, but let's we've listened to the colleagues who told us about the ground-based systems, and Russia and China, in fact, have now switched over from theory to real work. So that's why I suggest that we watch how the Rosatom manufactures this equipment. So please, the video clip.
Спасибо. Верните.
Thank you. So if we can get back to the presentation, please.
Ну, как мы уже говорили,
As we mentioned earlier, as regards the smaller capacity, we suggest floating land-based solutions. We've discussed the benefits, the same benefits as for larger plants, but as regards land-based stations, of course, the main benefit of the floating solutions is their mobility. Therefore, we'd better focus on the benefits of these mobile solutions. First of all, the potential consumers of the energy from floating stations are outlying areas, energy-intensive projects, the offshore sites, mining and processing sites. So precisely where it is not efficient to build a large power plant, but there is a demand for power supply. So quite often it happens that this demand is not stable, and there are certain time limitations, especially when we talk about the some mining sites. So here on this slide, we proceed from the objective requirements of our customers and looking at the generation of energy of such floating stations compared to other power supply units, you can see green marks everywhere, virtually everywhere, especially except for one short period to start power supply. Because objectively we understand that the construction of the power station is not such a fast project. You know, we have to. It takes more time compared to other types of power stations. 70 years of experience in construction and operation of transport reactor plants. This is our expertise. Today, Russia has ample experience in this, and you can see all types of reactors here, mostly small types of reactors that were used by Russia. First of all, icebreakers. So in the last pictures, you've seen that we are using KLT-40, which is a family of reactors that are used on icebreakers, and the first reference unit of academician Lomonosov, and the next family, Rhythm 200 and Rhythm ITM 400. These are the latest designs, actually, that are in operation right now. So I would like to say that when we started dealing with floating power units more intensively, we realized that one solution is not enough. So that's why we offer to you a whole family of different types. As I've said, academic Lomonosov is the first reference project of floating power unit, which is in operation today, 77 megawatt electric power. My colleague will tell you in more detail about the experience in its operation. 106 megawatt is another floating solution, first of all for northern territories, the territories in the north that we offer. The project, which is under construction, 104 stations are being built, 180 megawatt. These are RITM 400 reactors, mostly for north territories in the north. 100 megawatt is electric power, which we offer to our customers in areas where it's warmer, southern areas of the country, first of all. So as we look into this video, we've just seen this video clip, but of course it's impossible to squeeze everything into such a short clip because it's there are many things that we've done already, but 3 icebreakers with reactor RITM, KLT-40, the reactors with a long record already, a proven record, RITM 200. And in fact, while I was sitting here and calculating this, we either have built already or in the process of creating 19 more reactor units. So that's basically all we are doing, and we've done, and we are doing. We can say that it's already a product, a serial product that we have mastered already, that we can produce on a large-scale basis at a normal pre-planned rate. So there's nothing new in this. We have already addressed all the tasks, and we have resolved all the problems related to floating power units, so we can build them further to ensure to meet the capacities of our companies. So just a few words, the difference between the southern and northern versions. For northern territories, we use the same shell that was used for academic Lomonosov, the first reference project. For southern territories, we build an entirely new project, a floating unit which is 20% less in water displacement, and of course there's a difference in temperature of the cooling water, but in the meantime the life cycle has been increased, so instead of 40 we can use another fuel company, so it can be up to 10 years instead of 4 or 5 years, depending on the workload. So it might prove to be a very efficient solution, not only in northern territories, but also for southern territories. The concept also implies that we sell only electric power. Therefore, our business concept rests on build, own, and operate. Therefore, whatever we do, we can ensure also the communication lines, shore coastal facilities. We can supply power to the grid, and that's what we do. We also provide shipments. So the reactor cover never opens, which is done by the relevant organization, which means that there is no problem for operating these facilities on site. We can deal with everything on our own. So the transportation is a separate important task, and we've of course studied all the relevant rules and standards for transporting at long distances, especially as regards ships, cargo ships, which are capable to carry floating units as a cargo, which means that this is in line with complies with all international rules and standards. Although these rules require certain clarification so that all the countries could understand them in a similar manner. And also what we require from the customer is only coastal equipment and facilities that have that the customer has to ensure that they should be as close to the power grid as possible. And of course we are ready to participate in the selection of such sites as regards the construction of shore facilities. And also we have full understanding what happens on the territory of the Russian Federation, what happens on the territory of the customer country, our clients. So yesterday at the plenary session we declared that we work together, no policies of limitation, all the questions related to norms and standards. We count on the fact that the regulator, and first of all Russia and the countries we are negotiating with, we are going to discuss all these issues, and no doubt the International Atomic Agency participation is also necessary, so we could together find out what each country may do to deal with this task.
In this regard, we're very joyful that we're not alone, and we have our respected comrades and partners, and we have other competitors, companies, which are developing their technologies, and it means that it expresses the interest all over the place to such stations, and it means that we have to handle all these questions together in terms of standpoint of regulator, of course, providing safety. And short summary of my speech, we consider that SMRs are very important. This is very important part for remote regions and regions with clean, pure energy, and of course basic generation usually is brought by ground base station, and so that's why we cannot see any minuses at this kind of generation of SMR. So that's why buy them, please. So the next speech, it's the continuation of this very presentation. So this is detailed practice which is already developed in the floating units, NPP, academician Lomonosov. Paul Evgenich, you have the floor. So, dear friends, I remind you that we are lagging behind by 10 minutes from our schedule, so please consider it. So, as per the project of academic Lomonosov, so this is floating nuclear power plant with 2 energy power units, and it was put into commission in December of 2019. So it's been operating for 3 years, pretty in reliable way. So it's based in the port, and it's the source for different enterprises. So this floating unit was designed and constructed in St. Petersburg, planned, and everything was made according to the schedule of all the works. And today this NPP generates both nuclear energy and heat, and it's heating the whole city, Pevek, town Pevek. Requires the thermal demand of it. So this is the net of several power sources. The first thing is academic Lomonosov and Bilibinska power station, nuclear power station, and besides that there is another power station in Pevek, heat power station. So there were several golden deposits, and also operation of Pevek energy station. This is the beginning of 2022, and now it's been planned for 2025. So this station was built in Arctic surrounding, so all the questions on safety, nuclear safety, was there in the project, and it's been confirmed and established. Minimal influence on ecology, environmental issues, very good, and all the works which are there at the normal operation and emergency conditions of operation are applied and performed. So FNPP is operated by shift method. People stay in some major cities, and they are being transported by airplanes. So the fuel is transported by the sea, and all the units are in operation. Nowadays, all the design characteristics were confirmed and proved. So I won't go down into detail about all the characteristics, but the preliminary design, well, in the very beginning it was a transfer reactor unit, and it was completely confirmed by characteristics and parameters. And then next reactor was built, 200, and we talked about it already. So this project was super successful. It completely confirmed all the design characteristics of safety, and specifically it was very efficient in economic way. So this project in remote areas was completely competitive with one nuance. This project was performed with according terms, and one enterprise was planning to be getting energy, but unfortunately the terms were shifted, and our units were operated the lower capacity, but it was some intermediate stage, and in our perspective, we won't have such an issue. Thank you very much for this short but very serious speech. And now we're talking to the second part of our discussion. We want to hear those people who represent consumers, investors, international organizations. And the first word will be given to the Russian potential consumer, Minister of Energy of Primorsky Krai, Primorsky region, Mr. Leontiev. Can you tell us what can you see in this very technology for yourself? Good morning, dear participants of our forum, dear colleagues. Thank you very much for the invitation, for the participation in such a very serious issue of low capacity generation of nuclear energy. Our region, Primorsky territory, is very important for the Russian Federation. So we have commodities turnover 16% of Russian Federation, and we're planning to increase it. So within 5 years, because of growth of our region, so consumption of electric energy will be growing drastically by 1.1 billion units. So, and also we will connect new cities, satellite cities to the generation, and south part of our territory will be fulfilling all the necessities of energy. So it will be 200 megawatts, and by 2029 it will be 600 megawatts per hour. South part of Primorsky territory should be covered by some technical solutions. The most promising is the construction of nuclear generation of SMR and bigger units. And we can start it this very year. So I consider to start with SMR with 2 energy floating units in Japanese Sea and surrounding areas. Another floating power unit will be nearby in Slaviansky Bay. So it will be near China and Russian Federation. And according to the order of the President of Russian Federation, we already design all year resort and port, and it will be hosting a lot of gas. So it will be 5 seas and Baikal Lake project. And of course, we're interested in major number of tourists. It will increase economy of the territory. Besides that, we will increase power consumption. Right now, energy deficit today is 98 megawatts per hour. So we have systemic and complex approach to develop our territory. That's why small-scale generation is implementation of floating energy plants starting with 1 FPU plus auxiliary. So new challenges give us new opportunities, and we use them already, so that people of Primorsky territory will be satisfied with good energy generation. Thank you very much, Andrei. And now I would like to give a floor, the word to the representative of investors. What Sergei Evgenich would tell us about the future opportunity of funding of such projects. So please, you have a floor. Thank you very much. It's so pleasant to be at such a high-level forum. Well, I've prepared pretty large presentation, but well, I know that there were a lot of speeches, that's why I would be very short. So we are, since the middle of the last year, together with the partners of Rosatom, participants of the construction of the future generation operation of the floating power units for overseas markets. And first 7 units were built with the help of our company, and very soon I hope that we will implement this project completely. The main motive why we decided to participate in this project as a private business unit, in my mind, the main target is that there is a good, promising future behind floating power units. What we forecast internally in our group, it's the green energy issue, then sustainable provision of energy to the remote points of the world where we cannot feed them with other sources, and also provision of the sustainable development of whole regions. And very often we can talk about even countries in such sites where it's impossible to use other sources of energy, and also where energy limitations are existing as per developing of the business circles. Sometimes it's just whole regions. So in our estimation, it's about 733 million people still do not have stable, sustainable access to electricity in the world. It's a huge number, and more than half of it could be resolved by floating power units, and we cannot skip that. Insufficient, unreliable access to power all over the world, for example, in Africa, in Asia, even in the countries of Latin America, they are in top 5 limitations for the development of emerging economic countries. So more than 1-2% of GDP of Africa lost because of power outages. And what we can see out of technological solutions in the market, it's really power unit deployment. Why we consider a Rosatom solution, which are represented here, are optimal. Well, besides benchmark or referential project as per, for example, academic Lomonosov operation, and also Baimsky mining area FPU. Of course, we're talking about absolute leadership in the world, which has been accumulated within dozens of years as per operation of icebreakers. So nobody in the world has such experience. And all those projects which were announced, and actually they were stated by other world players, for example, French, American, Norwegian players, they're lagging behind in comparison with our project. And huge growth of interest to the project in the foreign circles, to the floating units are already displayed where we made pre-marketing. Saudi Arabia, Emirates, Kenya, South Africa, Seychelles Islands. And it's only beginning of our way ahead, and we haven't made aggressive marketing campaign yet. We think that growth of investment interest to this very branch will be there, and we will be like a pioneer as a private circle, business circle, together in partnership with Rosatom. So that's why in horizon of 5 years, major parts of the sovereign funds of the Middle East and probably of other countries as well, will be investing in the development of floating power units. And most probably it was our main motivation why we decided to see this project as the useful one, and in terms of energy supply of different sides of the world, but also it's very investment attractive. Thank you very much. So here you see that we have some kind of a picture. We have technologies, we have the experience, we have the understanding how to license it, and we have funds for it. This is the most important thing for the nuclear projects. And let's broaden a bit the frames of our discussion, and I will ask Mikhail Valentinich Chudakov, as the head of Department of Nuclear Energy of IAEA, to picture in brief this picture, this kind of a landscape in the view of IAEA as per SMRs and floating power units. Thank you very much. As we mentioned before, we evaluate the market every 2 years, and now we have about 80 projects in 20 countries. And so here we're talking about Russia and China in real-time projects. And for us, you see, I'm stretching out a lot, but we can put the Libinska nuclear station to SMRs in Chukotka, and I had an honor to be a director of this station for 8 years. So that's why I can put this SMR reactor as the first modular reactor unit in the world. And you see, a lot of countries, they want to see SMRs at theirs, especially in emerging economies, where they have non-developed infrastructure. That's why I completely agree with the fact that you see non-developed infrastructure, less investments in the construction period, and other reasons would influence this issue. That's why I agree completely with the previous speakers that we shouldn't use this project in all 19 directions of infrastructure. You see, of course, all these 19 directions of infrastructure should be there, but they should be scaled, let's say, from 0 to 100% independency of the importance of the application of some definite project.
Unfortunately, not everybody thinks in this manner, and sometimes it's a bit hard to deal with this issue. So we continue to work along these lines. We try to give assistance in case somebody builds SMR. The director launched the so-called SMR platform 2 years ago. We actually united the network as the activities of IAEA, the international organizations, creating kind of a single window. Even international agency addressing our department sometimes gets contradictory answers regarding the economies of SMR. That's why we've created this kind of a one-stop shop, just to meet the requests, to answer the inquiries. For example, in Jordan, they've been calculating the application of small saltless reactor, and they agreed with our comments in Jordan. We also created so-called nuclear harmonization and standardization initiative. The initiative that is aimed at combining two tracks, the industry and regulators, and sort of combining these two standards. It's like in aviation. If you buy buy a Boeing or a European Airbus and you fly to different countries, so you don't have to engage in relicensing. The main problem here is that nobody wants to flout the principles in regulatory activities. The new plant that we're going to produce has to be transported not only by ships, but we work with different organizations such as maritime organizations, but you have to issue to get a license, to adjust it to different regulators. So there's no uniformity in regulators. In Hungary, the regulators do not want to reject any principles, underlying principles, so the work is underway, but it proceeds. It's not an easy work, I should say. So we are trying to find the common points in documents, in provisions. So we want to work together, at least for the nearest future, and then we'll probably be able to work closer, more united, and we would think about creating uniform approaches and uniform standards that would have been ideal for promoting smaller modular reactors. When I'm asked about NESI, when your NESI project is going to finally win. So, and I'm telling them a joke when tourists are sitting on a Loch Ness next to the hotel, looking to the lake, asking the waiter when the NESI usually appears. He says it's usually after the second bottle of whiskey, sir, that you can see NESI. So you shouldn't expect that NESI will appear tomorrow or the day after tomorrow. So it's very difficult to create this commonality, but we continue to work, and we are thankful to the countries that they agree to that. So we perform work directed at training. This year we're planning to hold an international forum on small reactors in November. That will be the first forum of such scale, and so we invite everyone. Last November, we held the first symposium on floating power stations, which provoked much interest from many countries, security issues, safety, everything. So when I made a closing speech at the symposium, I also joked that the floating stations are the safest stations, because in case of a loss of heat carrier or in case of terrorist attack, there is a command: open Kingstones and sink the ship. So, but it's a joke, of course, but it's the safest station in the world, the floating station, power station. That's why we will continue to work, and we will continue to help disseminate these advanced technologies all over the world. Thank you, Mikhail Valentinovich, for very emotional and energetic intervention in our panel discussion. And now I would like to give the floor to our online participant, so we could hear the opinion of a representative of the International Industrial World Nuclear Association. Colleagues, is Mr. Lee here with us?
Mr. Lee,
yes. Hello.
Time for your intervention.
Okay?
Yes, yes.
And hope good afternoon to you, and I hope you can see my slides. So thank you for Rosatom and the invitation to participate at Atom Expo and the opportunity to talk to you about the international outlook for SMR deployment and at this distinguished panel. And I'm sorry I cannot be with you in person. So my name's King Lee, the head of policy at and industry engagement at the World Nuclear Outlook. So the outlook for nuclear and advanced nuclear technology is bright. At the international level, and policymakers are increasing looking to nuclear and advanced nuclear as part of the energy mix. I will go quickly. A lot of the topics already been discussed by the panel member. So I'll just highlight some of the key development recently. So at COP28 in Dubai last year, 22 countries signed a ministerial declaration to treble nuclear capacity by 2050. This is the first time at a COP conference that they formally recognize nuclear. So one of the areas that the ministerial declaration is highlight the commitment to support the development and construction of nuclear reactors, and including small modular and other advanced reactor for power generation and wider industrial application for decarbonization, such as hydrogen and synthetic fuel production. Include also at the COP, the World Nuclear Association with ENEC, supported by the IAEA, we launched the Efficacy Net Zero Nuclear Initiative. So at COP28, we collaborated and produced the industry pledge to support the ministerial declaration. This was signed by 120 companies in 25 countries and active over 140 countries worldwide, nation worldwide. So I encourage you to support the Net Zero Nuclear Initiative as we are preparing further activities, including COP29. And you can find further information about the Net Zero Nuclear Initiative at our website or at the Net Zero Nuclear website. Furthermore, there is increasing recognition on the role of nuclear energy to fight climate change as a source of sustainable energy. Recently, the World Nuclear Association supported the United Nations Economic Commission for Europe on a carbon neutrality project, looking at how nuclear energy can support the fight to reach net zero. So this project looked at a whole range of nuclear energy technology, including large reactors, SMR, and microreactors, and also the various different form of application from electricity generation, district heat, high temperature production, heat production. So these were released by the UN to different participants. I won't go through these slides, and I think this has already been touched on by other panel members in terms of various different advantages of SMR in terms of complementing large-scale reactors. And also it been mentioned that the number of SMR designs that are being developed worldwide and those that's already in operation. I will highlight a few areas that been touched on in terms of that require further development to facilitate SMR development and deployment. One area is we need suitable energy policy in different jurisdictions to encourage particular investment in nuclear technology and to export market. And it's already mentioned by one of the guests about financing. Now, nuclear is being recognized as a sustainable energy source and qualifies ESG. Companies are issuing green bonds to finance nuclear projects. So we we're looking forward to really encourage further investment into nuclear. Other guests and also IAEA mentioned about the work on international cooperation on the development of regulation and licensing SMR. This is particularly important to accelerate their development to help global deployment of SMR from vendor country to developing countries and to help development of novel technology. The other area that we need to globally work on is supply chain development, as we need to scale up the deployment of SMR, this including moving from first-of-a-kind project to serial production, the adoption of advanced manufacturing technique like 3D printing. What we, World Nuclear Association, is working on to help to support the development of SMR. As Mr. Kuchkov mentioned, we support the IAEA NETC harmonized regulation project. So the World Nuclear Association Cordell Working Group is working with regulators and IAEA to help to streamline regulations. And our supply chain working group collaborate with among industry members looking at advanced manufacturing techniques for nuclear components and other areas. So thank you very much for your attention.
Thank you, Mr. Lee, for your intervention and additional information regarding international activity in this area. And I would like to underline that Cordell had attempt to harmonize licensing activity many years, and maybe this attempt will be more successful. But now we close to our final stage, and I'm going to invite 3 other speakers who will represent the countries which could be considered as one of future places for SMR allocation. First colleague, Mr. Arnett Marques Peixoto from Brazil. You know, Brazil is one of very interesting country from point of view of geographic, and take into account that Brazil is one of length of Earth, but from other hand, a lot of space not covered by grid, not covered by electricity sources. And Brazil is not only maybe future partner for producers of SMRs, maybe also as partners and participants. Your words, Mr. Peixoto.
Thank you. First of all, it's a pleasure to me to represent ABDA, Association for Developing Nuclear Activities in Brazil, on this important forum. Okay, I will try to be very short, and as asked to me, is to present the opportunities and challenges for application of SMRs in Brazil. First of all, I would like to give a little contextualization. What is the situation in Brazil regarding the nuclear? Okay, Brazil has 2% of its matrix on nuclear, and even though if you in the next 30 years you double the total capacity, the percentage will be like that, no more than 2%. Because you are base hydro country, now you are decreasing the hydro. It was a few years ago 80%, now it's 50%. Water has become more a social issue than electricity generation, and you know Brazil has a lot of plantations and exportation. They need water, and then other sources of energy is coming. Talking about other sources of energy, you have to talk of renewables. And that's important for nuclear here. Brazil will have only wind and solar. Let's have a notion. We have 1 gigawatt solar deployed every month in Brazil. It's the plan is 17, and the deployment is 1 gigawatts per month. That's a lot. But that creates a space for nuclear. So the decision in Brazil is how the nuclear will be participate on that. Remember that Brazil has the knowledge of the whole nuclear fuel cycle. They can produce their own fuel, they can reach, okay? And we maybe need some scale up on the things to do, but you have this technology. Let me go for another slide. Could you change, please? Oh, okay, thank you. Okay, you see, this is Brazil has opportunity for every application of SMRs. You see, you have places on the country that are remote areas. That is ideal to use SMR. You have to integrate in the system. You have desalinization. Even though you are sitting on the very important source of water in the world, you have parts of Brazil that are dry, so you need desalinization. You can go for hydrogen production, go for the industrial process. You have every application, types of application. The decision is what to do. And most important, as growing the renewables, I mean, the nuclear plays a very important role on the stability of the grid, mainly the points of the grid. Brazil has a very modern grid of electricity. The whole country is integrated, but on the very points of the end, we need some more stabilization frequency, and frequency means rotating machines. If you want on the next 30 years to be out of any gas type of plant. So the nuclear plays a very important one. It can place in the big reactors, and it can place also as SMR reactors. So so you see very applications. I would say that in this case, Brazil may be a potential participant on the vendors or a potential consumer. We have, I mean, everybody knows that Brazil has a Navy program that produces more reactors, but this have a different path. If you consider energy, you need to have a different path how to implement, and maybe you be a consumer on that. But this development help us to understand better what's behind all the issues we have in SMR, like license, like energy, like economy, like many things. So we have the capacity to well choose. We are not newcomers on the field. Okay, next, please. Back. Okay, this is a kind of, just to remind, this is a kind of very high-level roadmap for the nuclear. What you need now, you need to promote discussions in Brazil and define exactly what will be the initial application. It will be desalinization, it will be on the end of the grid, to define exactly that. And then also encourage technical studies on the universities, on think tankers, on companies that develop these things. This we are doing. We have a forum for SMR in Brazil. We have a lot of contacts with the agents to use the SMR platform. We are creating the knowledge to even be a provider, even so to be a consumer of that. And you need help. You also need to help. You need to open to association with technology holders. So if the companies that have the technology, you are open to have joint programs on that. Finally, to keep my time in sync, you have it's not only the good things, you have challenge on this thing. Okay, we need cooperation, information for sure. You need to create a human resource on this specific area of SMR. Okay, we need to to apply the industry. We need to have an industrial policy on that. We need to include SMR and the electrical planning, on the country electrical planning. That's not easy. You can see, being at 2% to discuss with people who have contribute for the energy is not an easy thing. We need to also, all countries have communication with the public, communication because you apply in different regions and that, and you have also regulations issues that. But most important of all, we need some financing. As a developed country, it's not easy to get the money when you represent so few on the matrix of that. So we need the financing for this kind of project. I think this will give a brief idea what happened there. Okay, thank you.
Thank you. Thank you, Arpet. Thank you for your presentation. And our next speaker represents Indonesia. Indonesia, if you remember from geographical point of view, also very specific country with a lot of islands, with very very intensive growth of population. But I would like to invite Mr. Tapan Satidopura, not only as representative of Indonesia. I expect that he will highlight a little bit academic atmosphere around of small modular reactor development.
Okay.
Your words.
Thank you, Mr. Bishkov. It's an honor to be here. So the topic will be small modular reactor challenges and opportunities in Indonesia. So please consider this as like an invitation for collaboration. First, the national policy. So it's the energy transition in Indonesia. In general, we have three parts. First, related with coal power plant, we try to stop or reduce the power plant and increase the renewable energy. And the third one is try to add the new energy. So in Indonesia, nuclear is considered as new energy. And the interesting part here is in the stage 2, the second 5-year segment, 2030-2034, the government plan to have the words there, initial utilization of new energy, means initial utilization of nuclear energy. So that's the opportunity ahead. And going more detail, this is the composition. I will not discuss this, but the number 4 point, in the range 2030-2034, the government, the Ministry of Energy and Mineral Resources of Indonesia plan to have a specific number, the target, which is 250 megawatt electric in 2032. So it's the specific target decided by the government. So it's hopefully it's considered as an opportunity for us to collaborate and achieve this target together. And where the SMR will be. So in Indonesia, as you can see, we have many islands. Actually, we have 17,000 islands in Indonesia. So there are several sites being studied and evaluated in Bangka site and also Muria site, and we have other preferred site, potential site in West Kalimantan and also East Kalimantan. And East Kalimantan is planned to be the new Indonesian capital. The Indonesian capital will be in East Kalimantan. So it's the potential site. And even if we go further, there's an opportunity to go with the de-dieselization. If our SMR can go even more lower to the 10 megawatt electric like the Self-M in Russia or many other microreactors design, there are many potential sites in Indonesia which currently it is supplied by diesel. And based on our Ministry Act, the generating power cost is in the range of 20 per kilowatt hour in practical. So that's the opportunity we have. So the BRIN is the research agency in Indonesia. So the first strategy is, of course, absorbing external NPP technology, international vendors technology. So we have here around 80 SMR design. So the question, of course, can these SMR type nuclear reactors grasp the momentum of 2030, 2034, in particular 250 megawatt in 2032. So it's the question, can these 80 potential SMR finally landed and built, utilized in Indonesia? So we suggest vendors can engage with Indonesian company, because if it is the direct commercial plan, so the Indonesian business, energy business companies will be in the forefront. And BRIN, as a research institute, can act as the technical supporting organization, and maybe, if possible, as a co-developer of the design. Another challenge is, this is the NPP licensing scheme in Indonesia. So there's many boxes to be ticked. I mean, there's many boxes to be done together. So in the upper part, we said that it is important for the consortium. I already mentioned consortium. So we considered the engagement between the vendors and the Indonesian business entity should be established, and they can consider a real solution of the Indonesian energy demand. So to start, discuss, and have a good strategy on each boxes of this licensing scheme. For instance, the design aspect, the site aspect, and of course the business aspect. So we expect further initiative, this matchmaking we have in the right side, Indonesian energy demand towards economic development and net zero emission. We have a specific demand which is huge yet distributed. So like 1 gigawatt size nuclear power plant may be only good in Java Island. But for many of Indonesian island, it needs a small but many of nuclear power plants. So SMR is like fit with our geographical situation. In the left side, we have the technology push from SMR vendors. It's so many solutions, start from even 1 megawatt electric solution to 300 megawatt electric solution, land-based solution, marine-based solution, with cogeneration or without cogeneration. So we hope there's a really engagement to have a specific solution which agreed by the international vendors and the Indonesian business entities. So that's an important stage. So the second strategy is internal push. As you can see in the previous slides, among the 80 SMR, one of the SMR development is coming from Indonesia, coming from BRIN, which is an HTGR core. So we think there's another strategy. It's not a direct commercial strategy. So we push the national SMR technology being developed by BRIN, of course, in cooperation with experienced international strategic partners. So again, what the idea is to commercialize the HTGR, which being developed in Indonesia since 90s and now accumulated in the design what we call Plate 40. The idea is to have two steps scheme using exactly the same SMR. So from small prototype or demo in which BRIN in Indonesia legally have the privilege to build a demo power plant. And then the idea is to make this exactly same reactor to be the commercial reactor with the ideas of small but many. So it's not, again, big commercial reactor, but small but many reactors. And this is what we have currently developed a zero-emission hydrogen production system with two utilization target. First is de-dieselization, and second, cogeneration for hydrogen production with that numbers of performance. But of course, it's not yet fully developed, so we need international strategic partners to continue the design, and the next phase will be the design approval to our regulatory body in 2025. Hopefully we can start this, or yeah, that's the plan. So to resume, 3-point year 2030-2034, in particular 2032, with initial target of 250 megawatt electric is a window of opportunity in Indonesia for SMR to enter the Indonesian electricity or energy market and become the key factor in the national energy transition achievement. So this is the opportunity which I said this, so hopefully we can collaborate to achieve this. And we propose two strategy. First, of course, implementing the SMR technology from international vendors. And again, as one of the SMR is also coming from our institution, the BRIN. So the other strategy is to collaborate and push the internal technology via demo plan with two-step schemes. So demo, but the same reactor design then can be brought to commercial. So, but the point is both, because there are many uncertainty in this stage, so both strategy need a courageous and progressive collaboration between both parties, the international vendors and also the business entity, or maybe with the research entity. Okay, that's from me. Thank you.
Thank you very much, Tapan. And our last but not least speaker, Mr. Losa Tabashi, but I also would like to say some words about the Republic of South Africa. Oh, for my opinion, and maybe for opinion of people who work in nuclear many years, your country was and is the center of nuclear knowledge in sub-Sahara region, and you have and had some very interesting project, including SMR also. And please, Mr. Loisa, please demonstrate for our participants your view on this problem, SMRs. Thank you.
Thank you very much. The difficult about speaking last is that everything has been said or we've run out of time, and today it's a bit of both. My slant today will be very different because I fully support SMRs, and I think SMRs do present an opportunity to move us forward. And the continental approach that I'm taking is that if you look at Africa, we currently have very low access to electricity, and we need to transition ourselves to a bright continent. And this energy poverty is really not sustainable. It's something that we need to really move away from and ensure that we've got energy security for the entire continent. So SMRs indeed do provide an opportunity. If you look at the electricity maps, it does show you the carbon intensity of many different countries. And you'll see the green ones are very much decarbonized because they use hydro and nuclear, or one of the two. The others that still need to move, and I note that many countries have not subscribed to this particular app, but it does show that nuclear presents an opportunity to decarbonize. But also, one of the most important things for me is that if you look at Africa, Africa only contributes about 4% of CO2 emissions in the world. So it becomes very important to understand what is the problem that we are trying to solve as Africans. And my view is that the problem we're trying to solve is energy security and energy access as a primary principle. However, you cannot run away from the fact that whilst we are the least emitters, we are suffering the biggest in terms of climate change. So which means whatever trajectory we are on, we need to stay on course to ensure that we keep our carbon footprint very low. But primarily, we need to focus on energy security and energy access. As we're building 4 units in Egypt and 2 operational units in Cape Town, we can see the Cape to Cairo is really endowed with big reactors. I think in between, we need to have quite a lot of SMRs, and they present a big opportunity to help industrialize the economies. I won't go into detail on that. I think it's been covered quite a bit. And the South African framework, which is quite well articulated in terms of the integrated energy policy and the resource plan for electricity. But it's very important that we leverage on the expertise that we have from our research reactor Safari, which is 59 years old, and the Koeberg operational reactors, which are 40 years old. In terms of the areas of opportunities, there are very many, and that's been stated. The issue of small grids is very important. You need SMRs going in there. However, like I said in the other forum, we need both small and big plants. It's not an either-or kind of a debate. We need to focus on both. Many other diverse uses for application in the form of replacing the coal fleet, especially for South Africa, that is currently about 80% coal powered, heat power for power applications, off-grid applications, district heating, which is not a big problem in Africa. But water desalination is one of the biggest things, and hydrogen becomes one of the opportunities that we have. The pricing of electricity, you can see how it looks like globally. And if you want to hit the sweet spot of the energy trilemma, which is reliable electricity, low carbon footprint, as well as the affordability, you really need to focus on nuclear. Nuclear, you'll see the countries in the bottom end of the scale are the countries that do have some element of nuclear. And there's this SMR race that is currently happening, and it's good to see that plans are actually starting to go on being implemented, especially in China and here in Russia, and we look forward to seeing what will really ultimately become those that make it to the top 5, because I believe the top 5 will run the marathon quite well. And from our side, we're saying key enablers is that the harmonization policy, regulatory design standardization, and the banking is very important. Implementation, serial implementation does reduce the implementation costs. Socially, we need to have a very clear proposition, value proposition as to why nuclear power plants, why SMRs, and also the skills. I always say that skills follow projects. We've seen when you build in the UAE, there was no nuclear skill there, but we've got an exodus of skills supporting those programs. So skills is the least of the problem. The biggest problem is the projects. We need projects to be implemented and to move forward. And with that marathon, I just want to say that there's a strong case for SMRs, both in South Africa and in the rest of the African continent. We need to solve the real problem of energy deficit in our continent. Thank you very much.
Thank you. Thank you very much for so brief and very, I think, previous slide enablers. It's very important for many future vendors on this program. Colleagues, of course, we together with... извините, перейду снова на русский.
So I will get back to Russian language. So colleagues, together with organizers, with Rosatom Energy Project, we haven't been expecting that 13 speakers would be in the timeline of 1 hour and a half. However, we enlightened this picture of NPPs, of SMRs, and probably we haven't covered only several aspects. We don't have time for the major discussion. However, along the line, I would like to offer to ask some questions to our speakers. So we have first a hand to be raised. Greetings to you, colleagues. So I've heard in the speech, in the report, that in some definite period, block is put into retirement out of commission, and then it's been transferred to another site of Russian enterprise. Let's say that this block is in operation in South Africa, but to replace it and to put it into out of commission and etc., it's pretty long way. So what would you put instead of it in replacement? It would be the contractor will be resolving this issue by himself, or what?
So the backup unit will be supplied to the site where the fuel has to be replaced, so it is going to be synchronized, so the consumer will not notice anything. Nadezhda Fetisova, a new atom expert. So what's the status of the shelf project? Is there any news about the shelf project? Now let me answer this question as regards the shelf project. So we've done the feed on reactor unit, and a lot of research has been made in this area. So today we are dealing with the issue of the placement, the deploying the first pilot facility and the construction of the first nuclear power station. I think the final decisions will be made next year. Thank you, dear colleagues. Unfortunately, we run out of time. So let me make some brief conclusions. As we have seen today, there are vendors, those who can build small modular reactors, including other types of small reactors. So we've heard about the licensing of the systems, and there are also wishes and comments from manufacturers how to simplify the process, which is also important in this dialogue. We understand there are resources to fund the projects, because inevitably questions are asked, where can we find the sources? And we can see that there is a group of countries that really need this, that can be involved not only in this process, not only as consumers, but also as participants in the process, bringing in their intellectual and technical efforts. We can say that the path for SMRs is open. Now it's up to manufacturers, international organizations, and consumers. So we're going to work further. Thank you. Thanks a lot to all the participants, the audience, the speakers for interesting presentation. Sorry once again, so we were unable to expand this discussion.